All right, so get this. We're diving into something pretty wild today. You know how we're always on the hunt for new energy sources, right?
Right.
What if I told you the key to like unlocking a whole new world of energy? Could be in something we've kind of had all along. Information.
It is a fascinating concept, isn't it? We're so used to thinking about energy as something we like harvest, sunlight, wind, fossil fuels. But what if energy is like baked into the fabric of information itself?
I got to admit that sounds a little out there. But we've got some really cutting-edge research to unpack today, exploring this connection between information and energy across a whole bunch of different fields. We're talking fractals, black holes, even how our own cells work.
Yeah, and that's what makes this so compelling. This isn't just some fringe theory. We're seeing hints of this connection in physics, biology, computer science. All these different disciplines seem to be converging on this idea that information could be like a fundamental source of energy.
So where do we even begin to like unravel this? Feels like we're about to fall down the rabbit hole of theoretical physics.
Well, a good place to start is with something you probably remember from high school physics. E = mc squared.
Good old EMC-ware. Energy equals mass times the speed of light squared. Classic. But how does that tie into information? Last time I checked, there's no I for information in that equation.
True. But remember what that equation tells us. Mass and energy are interchangeable. They're two sides of the same coin. Now fast forward a bit and we have physicist John Archibald Wheeler proposing this radical idea. It from bit.
It from bit.
Oh.
Okay. You're going to have to break that down for me.
So essentially, Wheeler was suggesting that everything in the universe, all the stuff, the matter, the particles, even us, might ultimately come from information. He used the term bit as like the fundamental unit of information, like a 1 or a 0 in computer code.
So instead of thinking about the universe as being built from tiny building blocks of matter, we're talking about bits of information as the fundamental ingredients.
Right.
Like reality is one giant computer simulation.
That's a very simplified way of putting it. But yeah, you're getting the idea. And if we go with this concept that mass itself could be a manifestation of information, then Einstein's equation starts to have a whole new meaning. It's like a bridge between information and energy.
Okay, my mind is already starting to bend a little here.
Yeah.
But how do we go from these crazy equations and theories to actually harnessing energy from information? That seems like a giant leap.
That's where things get even more interesting. One path of research is exploring the idea of fractals and their potential to be like a bridge between information and energy.
Fractals, those crazy, infinitely repeating patterns you find in nature, like snowflakes, coastlines, ferns. What do they have to do with energy?
Well, fractals have this really interesting property. It's called fractal dimension, basically a way to measure how complex they are and how much information they have in a given space. Think of it like this. You've got a straight line. It has a dimension of 1. But a fractal, with all its twists and turns and self-similarity, can have a dimension somewhere between 1 and 2, or even higher, depending on how complex it is.
So the more intricate and detailed the fractal, the higher its fractal dimension, and the more information it's basically holding. Like comparing a simple line drawing to a super detailed photorealistic image.
Exactly. And here's the kicker. Some researchers believe that this higher information density in fractals could be connected to a higher energy potential. They're exploring whether changing the fractal dimension of something, like an antenna, could actually affect how much energy it can capture or store.
Wait, so you're saying we could build things like antennas or energy storage devices that are shaped like fractals to make them more efficient?
That's the idea, and it's not just theoretical. There are already experiments happening testing this very concept.
That's wild. So we've gone from Einstein to information being the building blocks of the universe to fractals potentially being like energy concentrators.
Yeah.
But you mentioned black holes earlier. How do those fit into all of this?
Black holes are in a lot of ways the ultimate test for this connection between information and energy. They're some of the most extreme things in the universe. And they have this property called Wittgenstein-Hawking entropy.
Black hole entropy. That sounds intense.
It is. Entropy, to put it simply, is a measure of disorder or randomness. What's fascinating is that the Wittgenstein-Hawking equation links the surface area of a black hole to its entropy, and the more entropy a black hole has, the more information it's thought to contain.
Hold on. So you're saying that the surface area of a black hole, this infinitely dense point in space, is somehow a reflection of how much information it has.
That's what the math suggests. And this means that even these massive cosmic things that seem to defy all our normal understanding of physics are somehow governed by this link between information and energy.
My mind is officially blown. We've gone from EMC portas to black holes.
Yeah.
All in like 15 minutes. And I have a feeling we're just getting started.
You're right, we've only just scratched the surface of this mind-boggling idea, but what's really exciting is that this exploration of information as a potential energy source
Hmm.
is taking us on a journey not just through space, but also into the inner workings of our own bodies.
Okay, you've definitely got my attention. Let's dive into that next. So we've explored this like mind-blowing connection between information and energy on a cosmic scale. But now I'm curious how this works in something closer to home, our own bodies. You mentioned that our cells use information to create energy.
Yeah, they do. And it's more intricate than you might think. At the heart of it all is this molecule called ATP, adenosine triphosphate. It's like the tiny energy currency of our cells, powering all our biological processes. Every time you move a muscle, think a thought, even just breathe, you're spending ATP.
Okay, so ATP is the fuel that keeps our cellular engines running.
Yeah.
But where does information come into all this?
Well, think of it like this. Our cells are incredibly complex machines, right? They need instructions on how to build and break down molecules, how to transport things around, how to respond to different signals. And where are those instructions stored?
I don't know.
In our DNA, which is essentially a huge library of biological information.
So our DNA is like the blueprint for our cells, and that blueprint guides the process of energy production.
Exactly. Creating ATP involves a bunch of complex biochemical reactions. Each step is carefully orchestrated by enzymes and guided by the information encoded in our DNA. It's like a perfectly tuned symphony of molecular interactions, all driven by information flow.
That's amazing. But if our cells already have this system for producing energy, why are researchers even looking at the information side of things? Can we really improve on what nature's already made?
That's the big question, isn't it? And that's what researchers are working on. By understanding how information controls ATP production, they think we might be able to optimize it, make it more efficient.
So we're talking about like hacking our cells to make them more energy efficient. Is that even possible?
It's definitely early days, but there are some really exciting areas of research. For example, scientists are looking at ways to manipulate the activity of certain enzymes that are involved in ATP production. By tweaking these enzymes, they might be able to increase how much ATP we get from the same amount of fuel.
Wow, that's incredible. So we could potentially get more energy from the food we eat just by fine-tuning the information pathways in our cells.
That's one possibility. And it goes beyond just improving our metabolism. Imagine athletes being able to increase their endurance by boosting ATP production in their muscles. Or people with conditions that mess with their energy production, being able to improve their quality of life through specific information-based therapies.
The possibilities are pretty mind-blowing. It makes you realize that our bodies are way more complex and adaptable than we usually think.
Absolutely. And this brings us back to the bigger picture we've been talking about, this fundamental link between information and energy that seems to be everywhere. From the vastness of space to how our cells work.
Okay, so we've got Einstein's equation hinting at this connection. Fractals maybe acting as energy concentrators, black holes seemingly controlled by information, and now our own bodies showing the intricate dance between information and energy production. But how do scientists even begin to make sense of all this? It just seems so vast and complex.
It is a huge challenge, but that's what makes it so exciting. One of the goals in this field is to come up with a unified equation that can capture this relationship between information density and energy across all these different systems, from the quantum world to the biological world to the cosmic scale.
A single equation to describe the universe. That's a pretty big goal. What would that even look like?
It's still a work in progress, but the idea is to make an equation. That takes into account different types of information density. You've got the fractal dimension we discussed earlier, which applies to shapes and structures. Then you have quantum information, which governs the behavior of particles at the subatomic level. And, of course, biological information, encoded in things like DNA, and the complex signaling pathways within cells.
So it's like trying to find a common thread that runs through all these different forms of information and how they relate to energy.
Exactly. And the equation would need to be flexible enough to adapt to each system's unique characteristics, while still capturing this underlying connection.
And what's the ultimate goal? What could we do with a unified equation like that?
The idea is to make a predictive tool, something that helps us understand how messing with information can influence how energy is generated in all kinds of different situations. Imagine designing more efficient energy harvesting systems, developing totally new energy storage tech, or even optimizing our own biology to improve health and make people live longer.
It sounds like this could be the key to unlocking a whole new era of energy abundance and efficiency. What specific applications are researchers exploring?
Well, let's start with something we touched on before, fractal antennas. The idea is that by designing antennas with certain fractal shapes, we can maximize how much information they hold, and therefore how well they can capture energy from the environment.
So we could build antennas that are super efficient at harvesting energy from things like radio waves or even sunlight.
Exactly. And it goes beyond antennas. Researchers are also exploring the idea of quantum batteries. They'd use the principles of quantum information to store and use energy way more efficiently than anything we have now.
Quantum batteries. That sounds like something out of a sci-fi movie.
It might sound futuristic, but the research is very real. Quantum systems are all about information processing, and if we can figure out how to use that for energy storage, it could be revolutionary.
Okay, so we've got fractal antennas, quantum batteries. What other mind-blowing applications are out there?
Well, what about bioenergy? Imagine engineering organisms like bacteria or algae to become super efficient biofuel producers,
Hmm.
or finding new ways to increase ATP production in our own cells, to treat diseases or boost human performance.
It's incredible to think about the potential, but it also makes you wonder, are we ready for this kind of power? If we could manipulate information to control energy so much, what are the ethical implications?
That's a really important question, and one that researchers are thinking about as this field moves forward. The power to change information is huge, and we need to make sure we use it responsibly. But amidst all these questions and potential challenges, there's a feeling of wonder and excitement in this field. We're at the start of a new era of energy, an era where information itself might be the key to a more sustainable and abundant future.
It's definitely a lot to wrap your head around, but one thing is clear. This journey of exploring how information and energy are connected is taking us down some pretty fascinating paths. I'm excited to see where it leads.
You know, it's wild. We started talking about Einstein's EMC-ESO, and now we're discussing quantum batteries and engineered biofuel factories. It really shows how connected all these ideas are.
Yeah, it's true. And what's even more amazing is we've barely scratched the surface. This whole idea of information being a fundamental source of energy, it's still pretty new, but it's already opening up some really crazy possibilities.
So if we take a step back and look at the big picture here, what are the key takeaways you hope our listeners get from this deep dive? Well, first off, I hope they come away with a sense of awe. You know, this research is really challenging our basic ideas about the universe and our place in it. It's making us ask questions like, what is reality actually made of? And what are the limits of what we can do?
I've definitely been thinking about those things during this conversation. It's pretty humbling to realize how much we still don't know about the universe and ourselves.
Totally. But that's what makes all this so exciting. The second thing I hope listeners get is a sense of optimism about the future. This research isn't just theory. It could lead to real-world solutions for some of the biggest problems we face, like climate change, energy scarcity, even human health.
It feels like we're on the edge of a new scientific revolution, one that could totally change how we think about energy.
Yeah, that's a good way to put it. And it's important to remember this isn't just about scientists. It'll take all of us working together. Engineers, entrepreneurs, policymakers, even everyday people, to make sure we use this knowledge wisely and ethically.
So what's the one question you want to leave our listeners with? Something for them to think about as they keep exploring this topic.
If information really is a kind of energy, what other possibilities are we missing? What other mysteries could we uncover? If we could understand the language of information better, I think we're just starting to see the true power and potential of this connection.
It's definitely given us a lot to think about. This has been a really incredible deep dive, and I want to thank you for sharing your expertise with us today.
It's been my pleasure. Thanks for having me. I hope everyone listening stays curious and keeps exploring. Who knows what amazing discoveries are out there waiting for us?